Good afternoon, everybody, and welcome to the second presentation in the speaker series on capital and the capitalist mode of power. Our speaker today is Blair Fix. He's a PhD student at the Faculty of Environmental Studies, and he has some sort of an unusual background as far as CASP is concerned, but that's true for everybody who does CASP analysis, I think. So he has background in physics and is also sort of a semi-professional musician. And he came to do this kind of analysis in a very roundabout way. And I think he got a little entangled in it, and he can't stop. So Blair just published a book with Springer called Rethinking Economic Growth from a biophysical perspective. And he also last year won the RECASP Essay Prize. So that's an annual essay prize that the journal, the Review of Capitalist Power awards every year. I think the quality of his research will become quite quickly evident, but I want to just make a preliminary comment that I think that this is maybe the beginning of a new approach to understanding economic growth, not from the viewpoint of well-being and from the viewpoint of utility and from the viewpoint of the welfare of society, but from the viewpoint of power. And there's been quite a lot of research done in trying to provide an alternative system of valuation based on measurements of energy. But what Blair is trying to do is something very different. He's trying to evaluate energy insofar as that it actually affects the hierarchies in society. And that's a new approach, and I think that it has a great promise to understanding the growth process quite differently than or from the way that it was understood so far. So without further ado, I'll let Blair begin his presentation. He will speak for about 40 minutes, and then we will take a break of about 10 or 15 minutes, and then he will speak for another 40 minutes or so, and then we will have a question and answer period. So thank you very much for coming, and Blair, please.
All right, thank you, Jonathan. So just a little outline before I get into the talk. What I'm going to do essentially is first show you some evidence why neoclassical growth theory, which is the dominant theory for understanding growth. I'm going to show you some evidence for why that theory is completely wrong. And then I'm going to basically, and there's really, the evidence that I'm going to show you, there's very little in existing political economy, to understand it. So it's really a blank slate. So I'm going to show you then my ideas of how we can understand this evidence. So let's get started. I'm going to frame things for you. Imagine you're an economics student. You just took, I don't know, Economics 101, and you learned about economic growth theory, and you're writing the final exam, and you have this question on the test, and it says, economic growth theory is a ... Is it A, a miracle of the free market, or is it B, a power process? Now, this is a contrived example, but it serves a purpose, and really how you choose to answer this question depends on where you come from, and especially what you've learned. If you're a good neoclassical student, neoclassical economics basically tells you that growth is a miracle of the free market. It's best accomplished through the free market. If, though, you care about empirical evidence, which I think if you're doing science, that's what you should care about, then you're going to answer B. That growth is a power process, and what I mean by power process is it involves concentration of power in large institutions. So we need to understand neoclassical growth theory, and literally tens of thousands of papers have been written on the topic, and I'm not going to get into the complexities of it. I'm really going to give you the very basic assumptions that underpin the theory. And if we can test those assumptions and they turn out to be false, then the whole theory really collapses. So there are, in neoclassical theory, many of you may be aware, there are a number of kind of foundation assumptions. One of them is utility maximization. Another is that firms are profit maximizers. For my talk today, the most important thing that you need to remember is that neoclassical theory, all neoclassical theory, shares this assumption about perfect competition. So what do they mean when they say perfect competition? Well, there's kind of a technical term. In neoclassical economics, perfect competition means that firms or companies are price takers. That means they can't influence the price. I'm just going to close this. They can't influence the price for their good. Now, why is this an important assumption in neoclassical theory? Well, it turns out that it's enormously important. So you're probably familiar, if you've ever taken an economics course, or even if you haven't, you probably know that it hinges on this idea of supply and demand. So we have these two curves, the demand curve and the supply curve, and they're really the mechanism that allows the free market to function. The free market is supposedly this equilibrium-seeking entity, right? So no matter where we start, no matter what price or quantity we start out at, the market will eventually arrive at equilibrium, and at equilibrium, magical things happen. Its allocation within the economy is optimal, wages are equal to marginal utility, and it can go on and on. So this idea of equilibrium and the equilibrium-seeking market is kind of the bedrock of neoclassical theory, including neoclassical growth theory. Now, where do these curves come from? Well, they're derived. The demand curve comes from consumers' marginal utility curves, and I'm not going to go into the details. The supply curve comes from firms' marginal costs, and again, I'm not going to go into the details, but it turns out, and this is very important, in order to have a supply curve at all, you have to have perfect competition and to be able to actually add up all the marginal cost curves of all these firms. So the economist Steve Keele puts it really succinctly. He says, without perfect competition, there is no supply curve. And if there's no supply curve, there's no neoclassical economics. So this is why you have to, neoclassical economists just hold to this idea against all odds, even though in the real world it just seems patently ridiculous. But they hold to it very dearly. Now, I'm going to use a slightly different definition of perfect competition for the rest of the talk, because I don't think that the neoclassical technical definition is very workable. To say that a firm is a price taker, let's say we want to measure that. How do you know if a firm has the ability to influence the price of its good? I don't know how you could even test that hypothesis. I'm going to take a different route, and one that is intuitive to me, and I hope it's intuitive to you. And imagine if a firm is able to influence its price, it's going to have some sort of power, and it's probably going to be large. The opposite end of that spectrum, when we can be pretty sure that there's a complete absence of any concentrated power, is if a corporation or a firm is as small as it could possibly be. And really the smallest it could be is one person. So I would be willing to say, if I found an economy that was 100%, everybody was self-employed, I would say that's perfectly competitive. That's atomistic competition. So this is the definition that I'm going to use moving forward. because I think it's more workable, and I think it captures the essence of the neoclassical assumption. So if you take this, then it leads to a prediction, which is that because I'm not going to go into the why this prediction comes about, but basically because equilibrium and the equilibrium seeking market is so great, the optimal growth path should be through 100% self-employment. Okay, it just kind of follows from the fact that perfect competition is so great. So this is a testable prediction, and I'm going to test it for you later. But before we can do that, we have this kind of overarching problem that I'm going to show you, which is measuring economic growth. Now, if you've taken a macroeconomics class, this question, it'll come up, and the answer will be, well, we measure economic growth with real GDP. That's just taking nominal GDP and deflating it by some price index. End of story. We move on, and we do all of the rest of our macroeconomics from there, and we never think about it again. But it's actually a fundamental problem, and I'm going to argue, I'm going to try to show you that we can't actually measure economic growth. It's impossible. So to measure the growth or the size of the economy, I mean, you have to really step back and say, what is it that's growing? And that's not immediately obvious, because if you kind of look at what you perceive on a daily basis, the economy is impossibly complex. You've got just millions and millions of different commodities. When we say that real GDP grew, what does that mean? So what is it that's growing? Well, I think to even ask that question and try to answer it, you have to have some sort of conceptual model of the economy. And this is the neoclassical conceptual model. The economy is a black box. And what that means is you can see inputs and outputs, but you can't see inside it. In fact, we don't even really care what happens inside it. Now, this model where we have capital inputs and labor inputs. It goes into some sort of black box, and then we have this thing called economic output. This model of the entire economy is inherited from the neoclassical theory of the firm. So in that theory, you just replace this word economy and put firm in it, a company. The company has capital and labor inputs, and it makes some sort of output. And maybe it makes, I don't know. The example in all the economic textbooks is widgets. I don't know why. But what you do then is, if you want to look at the economy as a whole, you just basically extend the metaphor. And literally, we treat the economy as though it's a single firm in neoclassical theory. This is literally, you have to assume this. Now, what is this thing called economic output? It's a nice arrow, but what does it really mean? This is Robert Solow. If you aren't familiar with him, he's an MIT economist, one of the most famous economists in the world. He basically founded modern neoclassical growth theory in a seminal paper in 1956. And here I'm quoting from this paper, basically outlining neoclassical growth theory. And this is his assumption right out. He just says it within the first 3 or 4 paragraphs. He says, there's only one commodity, output as a whole. Now, that's a pretty bizarre assumption, I think. But why does he do it? Well, this is really important. And I think he understood the problem, maybe. He says, it's so we can speak unambiguously of the community's real income. And this word unambiguous is so important, because I'm going to show you that if there's one commodity in the economy, we can objectively define and measure growth. If there's any more than one commodity, our measurement for growth is always ambiguous. Always. And there's no way around that. So neoclassical economists, to get around this, literally force the real world to behave like it's one commodity, and then you can derive everything from that. So I'm going to show you the problem if you haven't heard of it before. And I'm going to call it the measurement quagmire. And by the way, everything that I'm showing you about growth, about measuring output, also applies to capital. And they're literally the same argument. So if you read Jonathan's material, you'll find really the same arguments because it's the same problem of adding stuff up. So this measurement quagmire, I'm going to give you some really, really simple examples to try to show you how it works. So first, let's consider a single commodity economy, maybe one that only produces apples. So if in any given year we want to know how big the economy is, we just count the number of apples. We have a nice predefined unit, the apple, and we assume the apples don't change much year to year. So if in the second year we had 4 apples, we would say, well, there was certain percentage growth. And it's very easy. There's no ambiguity whatsoever. But if we add another commodity, and I've chosen to make that commodity a slice of bread, then it becomes more ambiguous. Now, you can always say I have 3 slices of bread and, 3 apples and 2 slices of bread. But we want to combine them. We want to say I want to have a single metric for growth. So how do we do that? Well, I'm going to make up an example here. So apples and slices of bread in year 1, 3 apples, 2 slices of bread. In year 2, things change. We add 1 more apple and take away a slice of bread. And then I ask you the question, you're the economics student. I say, calculate how much the economy grew. And you're diligent and you go ahead. Well, the problem first off is I haven't defined any units about how we should do this. And in fact, that's up to you. So there's a lot of different units we could use. Well, let's use physical units. Scientists like physical units. So maybe we'll use mass, volume, and energy. These are both food, so we can use calories very conveniently. And so I've done the calculations using kind of average measures for bread and apples. And here's the result. I get conflicting measures. The economy both grew and shrank. And how can that be the case? It doesn't make any sense. In energy terms, the economy shrank 15%. In mass and volume terms, it grew 10 to 15%. So you're left wondering, well, which is correct? And I'm going to tell you, but they're all correct. And they're also meaningless. So the problem is when you choose a unit, what you're essentially doing is defining how you relate to commodities together. So I'm relating apples and bread. If I choose mass, I'm weighing the apple and I'm weighing the bread, and I get basically a ratio. And in the case of the mass, in the units and the measurements that I've used, 1 apple is worth 2.5 bread slices. That's my fixed unit, and it should be fixed for all time if we're going to do objective measurement. If I use volume, it changes a little bit. The ratio is 2 to 1 apples to bread, or bread to apples. And if I use energy terms, again it shifts because bread is very energy dense. 1 apple is now only worth half a slice of bread. Okay, so we can see the problem is that defining the units effectively changes the ratio, how I relate 2 different commodities. And this is a very simple example with only 2 commodities. It just gets worse when we add more. So now I've chosen physical units of measure where there's actually nothing wrong with the unit, right? Scientists have spent literally 200 years defining more and more precisely the units that they use to measure mass and energy and everything. Okay, so everybody agrees on these units. So we don't have any problem there. And the uniformity of a unit is actually what makes it a good unit. If it's not uniform, it's actually useless. And this is the second major problem that we encounter when we try to add things up, is that economists don't choose physical units. They choose price, right? We're going to say the economy is worth $5 billion. So we're adding things up in units of price. But price is not constant over time. Okay, so right away you should realize, well, we've decided to choose something that basically violates the basic a property that makes a good unit. So I'm going to show you an example of what happens when we do this. And I'm going to use cars and computers now. And what I'm doing here now is really literally out of Jonathan and Shimsham's book. They do the same thing with capital, but it's such an illustrative example that I want to do it here. I am going to use real data now from the US for car production and computer production. So this is the physical quantities of these commodities. It's pretty well defined, and then I'm going to try to calculate real GDP. Now, when you calculate real GDP, essentially what you're doing is fixing prices. Because we know we have inflation. All economists know that inflation is a problem. And we want to isolate the real change in the economy from just pure inflationary processes. And economists pretend that this is a simple objective process. Well, so let's look at prices. Here's how the price of a car and the price of a computer have changed over time. Car prices have inflated, as most commodities have, but computer prices have come down. They've moved in opposite directions. And so the problem becomes, what year should I use to calculate real GDP? Because essentially when you calculate real GDP, you're choosing a base year and holding those prices fixed for all time. But it's ambiguous. And there's often an appeal to this idea of equilibrium. We want to choose when prices are in equilibrium. But there's no way to know when the economy is in equilibrium. So in actual practice, economists just basically choose at random. So I'm going to show you what happens if I choose a base year of 1980. I get the blue curve. I get quite a bit of growth. If I choose the base year of 2008, I get almost no growth. So I get these kind of radically conflicting measures of real GDP. And you ask me which one is correct. And I tell you they're both correct. But they're both meaningless. Okay? So I hope you see I'm trying to drive this point home. When essentially if the price fixes the ratio between two commodities, that in year to year that ratio changes. It's like having literally a ruler stick. I give everyone in this room a meter stick. And you go out and make measurements in the real world. But unbeknownst to you, all of your meter sticks change at different rates. And you come back and you compare all your measurements, and they're all different. Well, who's right? You're all right. And all of your measurements are meaningless. It's the same problem. Now, you might have said I cherry-picked data. I picked cars and computers, so I cherry-picked some prices that have changed in very different ways, but actually, in actual fact, I haven't. So this is data from just 10 commodities that I picked from the Consumer Price Index. And if you're looking on your charts now, this should be on there. The take-home message from this chart is that prices have, yes, we have inflation. Yes, everybody understands that. But we have differential inflation. And that's the key problem. Price changes wildly divergent. So, for instance, electricity has, the price of a kilowatt hour of electricity has not changed very much over the last 80 years in this graph. Very little change, but an apple has undergone tremendous inflation. Okay, so we have differential changes in price. Okay, this is the changing meter stick. It means our unit, what we've chosen to use is prices, and it's just useless. So this is the final result. Here are conflicting measures for real GDP in the US. The official measure is the blue. The green, I guess your paper is not color-coded, but up here the green is what's called a vintage year. So I went and found a calculation for real GDP using 1995 prices. And it ended in 1995, so I forecast it forward using official data, but that's kind of beside the point. And then lastly, the red is from this website called Shadow Stats, and it's basically a an economist who uses different ways of calculating inflation. And we get, I mean, his metric is completely different, okay? So the question is, and the US government is aware of this problem, and they've kind of tried to sweep it under a rug, and they've adopted this new way of calculating real GDP. I don't want to go into it, but it doesn't solve the problem because there is no way to solve the problem. There's no unit for calculating real GDP. Okay, so these measures conflict wildly. But it gets even worse than that because the national accounting system adopts a neoclassical perspective. And in the neoclassical perspective, what ultimately consumers are doing when they purchase a commodity is getting utility from that commodity. And if the commodity gets better, theoretically, qualitatively better, if your computer, for instance, gets better, you derive more utility from that better computer. And that is, economists say, a quantitative change. The economy has grown, right? If your computer gets twice as good as it was last year, that means the economy, in terms of the computer, has grown. It's doubled, okay? So economists want to take qualitative change and turn it into quantitative change. And I mean, I think it borders on the ridiculous. This is a computer in 1960, and we have to answer the question, how much better is this computer? Is it 10 times better? 4 times better? What are we measuring? Are we measuring processing speed? Are we measuring the quality of the screen? I mean, and there's just no objective way to do this. And if you're interested in how economists try to measure qualitative change, you should read Jonathan's PhD. I've read this chapter many times, but he really debunks how economists try to measure quality change. You really can't do it, okay? So, the problem, I'm going to summarize. The problem with measuring growth is that, one, the unit you choose to measure is always subjective, but it basically affects the measurement of growth. Two, economists use price, which violates the basic requirement of a good unit to be fixed over time. And three, we attempt to transform qualitative change into quantitative change, and which is inherently subjective. So every step of the way we're making subjective choices. Now there's nothing wrong with making subjective choices. It just means you can't claim to be an objective science, but that's exactly what neoclassical theory claims to be, okay? So every time we make a subjective choice, essentially we get a different measure of growth. And so if we have millions and millions of different conflicting measures of growth, that's the same as basically saying our measurement is useless. So I'm going to make the claim, I think it's the only reasonable claim to take from this problem, is that it's impossible to objectively measure economic output. Completely impossible. We shouldn't even try. But this leaves us with a really big problem. If we want to have a growth theory, but we can't measure how the economy grows, what do, right? If you want to have a scientific theory, you have to be quantitative. You have to measure growth. But we can't do this. So what's the way forward? How do we get out of the measurement quagmire? And my solution to this is to not even try to enter into it. I don't think we should try to measure output. I think it's a losing battle. It's impossible. So what I'm going to propose is we really leave political economy behind and take a step back and look at physics and thermodynamics. Now, let me just tell you about the laws of thermodynamics. There are two laws. First is the conservation of energy and matter. The second law is called the entropy law, and essentially what it tells you is that if all systems, if left in isolation, will come to an equilibrium. I think actually neoclassical economists stole this idea when they were talking about the free market. But this concept of equilibrium in thermodynamics is completely different in the sense that there's no known violation of it. In the entire history of science, the law is about 250 years old. There's never been a single violation to the laws of thermodynamics. There was a famous physicist, Arthur Eddington, who said, if your theory is against the laws of thermodynamics, there's nothing for it. Throw it out, okay? Now, without flows of energy, all roads lead to equilibrium. So I'm going to show you how and why this is the case. So first of all, let's define equilibrium and at least give you a picture of it. So say you take a glass of water. I have my glass here, and it might be cold, and I put it in the room and I stand back, and after maybe half an hour, it will have arrived at room temperature. Automatically, I don't have to do anything. That's the equilibrium seeking quality of all systems. Okay, so now it's at room temperature, and barring any new introduction of energy, it will stay there for the rest of time, and it will be completely boring. Literally nothing will happen of interest. All you'll have is the little microscopic motion of the atoms. Okay, so when you think of equilibrium, literally a standing pool of water, static, that nothing happens for eternity, literally. Now, we can disrupt this state very easily by introducing energy, and we can introduce energy in many different ways. But one way, let's imagine now we have a bottle and we put a pump on it, so it circulates water up to the top. And if you do this, you will immediately get some sort of spinning vortex, right? Now, the vortex is a structure. It's a structure that emerges out of the water spontaneously when you add energy. And the energy is basically in the pump. It's pumping water against gravity. The structure, we would call it an emergent property. We can't really predict exactly what will happen, but we can say that if we add energy to any system, usually some sort of structure emerges out of it. And what's important also is if I stop the pump, almost immediately this structure will go away and the water will come back to equilibrium. Here's another example with water. Now this looks like cells, like living cells. It's actually not. It's water on a hot plate. If you put a very thin layer of water on a hot plate, and you can do this at home, you will get convection cells. And they're basically the water's flowing. Hot water is rising to the top and it cools down and goes back down. So you get this circulation, and that's what it looks like if you do it very nicely with a very even hot plate. So what the energy source then is the hot plate. Energy is flowing through the system, and these structures spontaneously emerge. Okay? Where am I going with this? Well, we can generalize further. Not only physical systems, but literally all, not only inorganic systems, but literally all systems that exist in the universe are subject to these laws. So life, physicists and biologists have known this for a long time, life requires energy. Okay? So this is an amoeba. How does the amoeba maintain its structure? Well, it has a metabolism. It eats stuff, food, right? So then it takes the glucose in the food and metabolizes it, breaks it down, gets energy from it, and using that energy, it can maintain its structure. Well, when something dies, basically its metabolism is stopped and it will basically break down. Its structure will go away. So life basically obeys these laws that it requires energy flows to maintain its structure. Now, we can't predict what structure will emerge, but that's not the point. The importance here is the energy flow. That was a single-celled organism. I can generalize to a multi-celled organism. Nothing changes. Okay, all multi-celled organisms have some sort of metabolism. They take in energy and use it to maintain their structure. I can generalize even further to bigger and bigger systems. This is an ecosystem. It's the Amazon rainforest. gets its energy from, well, all life on Earth gets its energy from the sun, ultimately. So solar energy. And think about how could we stop this ecosystem from functioning? Well, imagine we transport it to the North Pole. What lives at the North Pole? Well, certainly not rainforest. Tiny organisms live in the ice, okay? Well, this hugely organized system requires an enormous input of energy to maintain its structure, okay? Going even further, the economy, or if you like, a human system, is a physical system. It's embedded in the environment. And it's no different than any of the other things that I've showed you, except it's much more abstract, it's much more complex, but still the basic principle is that human economies require energy. Okay, this is Hong Kong. It would not function without constant inputs of energy into the system to maintain the structure. And if we want to build more, to grow the structure, then you need to use more energy. So I'm basically arriving at now kind of my end point of my argument is that energy is this the flow of energy is this universal organizing principle across all of the science, across all known systems in nature. And we're not immune to it, right? We are part of nature. And so the conclusion, if you want to say what is growing when the economy grows, well, thermodynamics tells you that we have to increase energy consumption if we want the structure of the economy to grow. So what we're doing when we use energy is incredibly complex, but I'm abstracting from that. I'm not trying to measure what exactly we do with the energy. I'm just going back to the very beginning and I'm saying, how much energy do we use? And since it's such an important principle, I'm going to use energy consumption as my measure for economic scale. Now I hate using this word, but I end up doing it, otherwise nobody understands. When I say economic scale, what I really mean is biophysical economic scale. It has nothing to do with money in any sense, so don't get confused. I'm not saying that energy is equivalent to GDP. Many people have tried to go down that route. It's a dead end. I'm not saying that in any way. I'm saying I'm going to measure the scale of the economy, the physical scale, in terms of energy. So this is now my unit for growth, and I can now test this prediction that I said neoclassical economics makes, which is that growth should be best occurs through 100% self-employment. Now, we already know that no country on earth has 100% self-employment. So to give neoclassical theory the benefit of the doubt, I'm looking for two things if neoclassical theory is going to be supported by evidence. Either self-employment should remain constant as economies grow, or it should increase. If self-employment and perfect competition is so great, as economies grow, self-employment should increase. That would give you a positive correlation between energy consumption and self-employment. And we can test that really easily. So I'm going to look at self-employment now, at first at the global level and then in the US. And what we find is not good for neoclassical theory. We find, so here on the bottom scale now is energy consumption per capita, and on the vertical scale, self-employment. And self-employment as a fraction of total employment. Okay, so every dot is a country. I've labeled some of them. The poor countries are down here. That's Cambodia and then Luxembourg up there. What's important is we have a negative correlation, in fact, a very strong negative correlation, which means as countries increase energy consumption, very predictably, they decrease self-employment. Fewer and fewer people are self-employed. And this is the opposite of what I told you neoclassical theory might predict. Okay? So it doesn't bode well for the theory. So this is a snapshot in 2008. I'm going to now move to the US and look at a time series. Now, first of all, it looks like a positive correlation, but I've done that just to show you how nicely the graphs line up. But actually, I've reversed the curve here. So blue is self-employment as a fraction of total employment, and it belongs to this scale. And notice the scale is inverted, so going up is actually a decrease in self-employment. So what we have is a very strong negative correlation here in the US over time between energy consumption per capita and self-employment. So as energy decreases, as energy consumption increases, self-employment decreases. And when it levels off too, the same thing happens with self-employment. So when I first discovered this, I was blown away. I still am blown away by this relationship. But the question is, if as economies grow, people are not working, they're stopping, or they leave self-employment, where do they go? They could go to small firms, firms of 10 people or 20 people, or mid-sized firms, or large. We really don't know. All we know is that they're leaving self-employment. So the next step is then to look at corporations. And I'm going to look at the biggest corporations. So what I'm going to do is calculate, I found good data for the largest 10 corporations internationally. So here on the vertical axis is the 10 largest corporations in each country in terms of their employment as a fraction of the country's total labor force, or the total employment. And then again on the horizontal axis is energy consumption. So positive correlation, which means as energy consumption increases, more and more people work for large corporations. So they're leaving self-employment, and they're not going to mid-sized companies at all. They're going to the biggest ones. So again, this really contradicts neoclassical theory. If growth is this free market process, why then are these large companies getting bigger and bigger and bigger as we increase energy consumption? It's directly the opposite of what we would expect. So this is, again, a snapshot in 2008. And I'm going to now move to the US time series. And I use the US because it's got the best data. So again, red is energy consumption, now per labor hour, and blue is corporation. Now, because there's so much more data now, I'm using the largest 200 corporations, fraction of total employment. And incidentally, this number is just completely arbitrary. Largest 200, largest 400, largest 20, it doesn't really matter. I just picked it arbitrarily based on what data was available. So again, very positive correlation. And importantly, it goes up, right? Until 1970, massive growth in energy consumption, massive concentration. I'm going to go for another 10. And then decline afterwards. Okay. The last thing, certainly governments are not perfectly competitive. They're not part of the free market. So I'm going to look at how government employment changes. Here's energy consumption per capita versus the government's fraction of total employment. And again, it's a global snapshot. The correlation is positive. It's much looser than with corporations, but it's still there, right? Still a positive correlation. So more, as the economy consumes more energy, more people work for the government, which contradicts neoclassical theory again. Last graph here is the US. Again, positive correlation between energy consumption and government employment, relative employment. So what we have now is a whole bunch of evidence that just really contradicts neoclassical growth theory. So we can, I think, conclude that neoclassical growth theory, the assumption that growth is a free market process, is just flat out wrong. There's no evidence for it. So it's really nice to prove a theory that you hate wrong, but the much harder task is to then make a new theory. And I'm going to tell you my theory, but I think I've talked for 45 minutes. So let's take a break and I'll tell you my ideas afterwards. Okay, so here the rest of the my presentation is my explanation for this this data that really, as far as I have been able to parse from the literature, there's zero explanation in political economy for this evidence. So I'm making up my own. So I hope it is plausible to you. So my hunch is this idea that as energy consumption increases, social organization has to scale in some manner. And I'm going to make qualitative arguments to this extent. I'm not even really aware of how I would make quantitative arguments, but maybe you can. So let's imagine a hunter-gatherer society. Hunter-gatherers get all their energy mostly from food, so very low energy consumption. And here's just a typical dwelling that a hunter-gatherer society might construct. And I want you to imagine how many people would be required to make this. And I've never made one, so I don't really know, but I can guess 1 or 2 could make this thing in a day. So the principle that I want to advance is that the number of people who are required to coordinate within a society is somehow scales with energy consumption. So hunter-gatherer societies were very small and insular, probably 100, 150 people in a tribe. And on any given project, a handful of people were required. If we go up, we introduce agriculture and large-scale agriculture. Probably the first large-scale agrarian societies were in the Middle East, and they used irrigation. They got much more, they had much more energy available. And they built things like the pyramids. So we can ask, well, how many people would work together on a project like the pyramids? And I use work together in quotes because they were slaves. They didn't really want to do it, but nonetheless they did it. And actually the fact that they're slaves is important for the arguments I'm going to make later. But, estimates vary, but maybe 10,000 people worked on the pyramids. We don't really know, but orders of magnitude more than in hunter-gatherer societies making this hut. Now we go to the present day and we now use fossil fuels, enormous amounts of fossil fuels. This is the Three Gorges Dam in China, in the Yangtze River. As far as I know, one of the largest, if not the largest, construction projects ever undertaken. And there were about 30,000 construction workers working on site, let alone all the people who were making all the stuff that was necessary to construct this. So, orders of magnitude, again, kind of more people working together. So the question, this principle that I'm advancing, and I don't really have a good explanation for why it should occur, but it's the idea that more people have to work together as we use more energy. So then the question is, how is this accomplished? How do we scale social organizations? There's got to be some mechanism to do it. And before we move on, we have to do something that people in social sciences, especially the humanities, are very reticent to do, which is to realize that we're animals. Humans are animals. We're primates, and we share a genetic heritage with all other primates. And all animals, I think it's quite obvious to us as outside observers, all animals have inherent limitations. And I think humans are no different. We have inherent limitations. So, very interesting work has been done with primates by an anthropologist named Robert Dunbar. And he found this, for me, a fascinating relation between brain size, so the neocortex, which is kind of the primate brain, the relative neocortex size versus group size. So all the dots here, are different species of primate, and there's a very strong positive correlation with the relative size of the neocortex and mean group size. And Dunbar argues that this is a causal relationship, that coordination between individuals is a very computationally intensive task. You have to think about how you're relating to everybody else and how their interactions affect you and how they might stab you in the back, and all these calculations that, if you think about it, if you watch a soap opera, people are doing all the time, but you just don't realize it. So he's basically saying there's a causal relation. Now these are just primates excluding humans, and then Dunbar says, well, we know the size of the human brain, the relative size of the human neocortex. If we extrapolate this trend, what is the predicted size for human groups? And he makes that leap, and we should, incidentally, consider this very exploratory. It's come to be known as Dunbar's number, and the exact number is 115, but the margin of error is so large that we should realize it's between 100 and 230. It's kind of entered pop culture, and actually in corporations, this idea that humans are only capable of interacting and maintaining relationships with 150 people. It's exploratory, so we really need to be careful with reading too much into this. But my reading of it is that there is pretty good evidence that we have genetically and capacity of our brain a limited ability to maintain human relationships. How many that is up for debate. But there is evidence that that supports Dunbar's kind of region of group size. Here's a really interesting plot from Stephen Wolfram analyzing Facebook data. How many Facebook friends people have. So we have a distribution, and obviously some people have very few and some people have a lot, but the vast majority are in this chunk here somewhere between 50 and 500. And the median is 342, which is right around where Dunbar predicts, And so I buy into this argument that there are inherent limits to our capacity to maintain social relations. There's a big spectrum within that, but certainly I don't know of any person who is able to maintain 100,000 friends or 1 million friends, and yet we have institutions. Walmart has 2 million employees. Do all 2 million employees interact on a daily basis? No. Well, we know that intuitively. So, following Dunbar's evidence, I think I'm going to suppose that a social coordination mechanism has to limit the number of required human relations. So, as group size increases, what kind of mechanism does this? Does the market do this, right? Neoclassical economics says that the market is this magic organizational mechanism. The invisible hand, magically, everybody works in their own self-interest, and magically the invisible hand makes everything work out. Society is, everything is great. Can the market actually do this? Well, no. It's pretty easy to show. What is a market interaction is basically a human interaction involving a price. So we basically take a qualitative interaction and add some sort of quantitative element. But it really doesn't remove the need for face-to-face interaction between individuals. It certainly makes things easier, right? But if I trade using money, but I still have to interact with other people. So let's imagine as group size increases, how many more people can you trade with or interact with? So the blue person here in a group of 3 can trade with 2 people. In a group of 4, you can trade with 3 people, and you see the trend, it just grows linearly with group size. one less than the group size. So if we're talking about the pure free market where everybody's self-employed, the problem is if we have 1 million people somehow working together, that they all have to interact somehow with everybody else in the market. And that, I think, is just unfeasible given this evidence for limitations in our ability to interact with other people. So the market is out. There's really no evidence for it. But there is another mechanism that is, I think, neglected in political economy, but is incredibly important. And it's this idea of hierarchy. So we have here a hierarchical institution, and you're the blue person, and the question is, how many people do you have to interact with? Are you required to? Not that you actually interact with, but who you're required to interact with. And it's very easy to see. You have to interact with your direct superior and your direct inferiors. Now, the number of people who are below you is a function of what's called the span of control. And this is all over the field of management studies. It's basically how many people does any given manager control. And that's arbitrary, right? But we assume that it's fixed throughout the hierarchy. And in my drawing here, I've assumed a span of control of 2. So every manager looks after 2 people, which means they have to maintain 3 social relations. And the important thing is that if you look, I've added in every successive organization here another level to the hierarchy. So I go from 7 to 15 to 31 people, but each blue person still only has to interact with 3 people. So it's kind of magical how this happens. We can scale the group size, but any given person is required to interact only with a fixed small number of people. So I'm going to make a very bold claim that hierarchy is a universal scaling mechanism throughout all of human history, okay? Probably the boldest claim that I can make with a straight face. How do we test? And I'm not just going to say this, I'm going to look for evidence for it. Well, how can we look for evidence? Let's go back here to these hierarchy diagrams. So let's assume that hierarchies have a fixed span of control. So this is a simplifying assumption. If we do that, we can look for how the number of hierarchical levels varies with the group size. So this group, whatever it is, has 3 levels. 1, 2, 3. And 7 people work in it. This institution has 4 levels and 15 people work in it. What you can see now is that the number of levels is going up linearly from 3 to 4 to 5. But the number of people in the group is growing exponentially. And you can see that if you just add one number to the n, I get 8. And that's a power of 2. That's 2 cubed. 15, I add 1, that's 16. That's 2 to the power of 4. Add 1, that's 32. That's 2 to the power of 5. So when I have this, I have exponential growth in the size of the institution, linear growth in the number of levels. So this is a pattern, a very specific mathematical pattern that I can look for as evidence of hierarchy functioning as this scaling mechanism. So let's do that. We can look at hunter-gatherers. Now these are modern hunter-gatherers because you really can't find evidence for hunter-gatherer societies that are extinct. What we have down here, don't pay attention to that jargon. The numbers down here are the number of hierarchical levels, the number of administrative levels. And this is the group size up here. So we have linear scaling in hierarchical levels, and because these are going up by powers of 10, we have exponential scaling here. That's exactly what we want. Okay, so this is really good evidence for hierarchy functioning as an organizing principle among hunter-gatherer societies. And incidentally, they're very small, right? The biggest one is about 1,000 people. Here's evidence from agrarian empires. So, yep.
Can you go back to the
Yep.
previous chart? Can you explain the spread there? What are the different symbols here?
Oh, well, it's a box plot. So it's showing you the most of the data, the interquartile range
I see.
here. And then, so there's a spread in the data. That's all.
So each symbol is essentially an observation from a different society?
I believe so, yes. Yes. I haven't read this paper in great depth, but they make the graph more complicated than it should be. I would just use averages, but they show you the spread of the data. Okay, here's a different graph. We reverse the scale, so now the number of hierarchical levels is vertical and the population is horizontal. These are historical agrarian empires, and this data comes from Peter Turchin. And again, so we have exponential growth in the population because we have powers of 10 and linear growth here. So this is, again, very strong evidence for hierarchy, this very simple model of hierarchy being used as the organizational principle.
Can you explain this chart a little bit more? So if you take one society, say you take France, which is the round black symbol. So as we move from one observation to the other, are we moving through time here? Or?
You can't tell which way in time because he didn't label it.
Okay.
It's not clear, but you are moving through time.
I see.
Yeah, each empire has its own symbol, and you move through time. I don't know. You could be moving that way as you go in time. He didn't label it. But,
Okay.
yeah.
Thank you.
Okay, but it's interesting though. So these you can see how these single societies add administrative levels as they grow, or take them off as they decline. Now, coming to the modern era, really the dominant institution is the corporation, and you find this exact same trend inside the corporation. So now we have a number of employees is the measure of group size, and we have administrative levels here. Now, the plot looks different because they didn't do an exponential scale here. This is a linear scale, so the plot curves. So it's actually, technically, it's a logarithmic curve, which is what we want. But I didn't want to get into the mathematics of it. But this again is evidence for the exact same phenomena of hierarchy being used as an organizational principle, and the number of levels increasing as we add more people. So I've said that hierarchy is universal throughout human history as a way to organize and get people to work together. But how that actually happens is actually not universal at all. It's very specific to the time and place. And it involves really legitimacy. In a hierarchy, you have one person at the top, and they have the right to rule. But the question is, why? How did this happen? And there's this really great quote from Game of Thrones, which I love. I'm sure everybody likes Game of Thrones here. But this character Varys says to the character Tyrion, he says, "Power resides where men believe it resides." And this is a great kind of synopsis of ideology, right? Those at the top are in power because we believe they're the rightful holders of power. They're legitimate. If we don't believe that they're legitimate, then we overthrow them. Okay, so you have to have this ideology to maintain a structure of power. So the question is, what is this ideology? Well, throughout almost all human history, I would say the ideology is religious in the sense that it appeals to something external, the gods, right? So in ancient Egypt, the pharaoh derived his power. He was thought to be a god, I think. I'm not an Egyptologist, but he derived his power from religion and appealed to divine power. The exact same is true in feudal Europe. The kings of Europe claimed to have the right of divine kingship, and all the other strata of society were legitimized by this natural order that was said to be dictated by God. The same is true in feudal India. The religion changed, it's Hinduism, okay? And you could go on and on and on and look at how religion has justified social hierarchies throughout human history. But as we move to the modern era, the gods are out, right? We still have a religion, but it's not the dominant ideology. And Nitzen and Bickler use this idea of a secular religion, which I think is fantastic. We have a new secular religion that justifies our social hierarchies. Well, what is it? Well, it's capital. The belief in capital. So capital is the dominant institution, I'm going to argue, for forming social hierarchies. But before I go any further, we have to, the word capital in political economy is ambiguous, so we have to differentiate what we mean. Capital has this dual meaning of referring both to machines and infrastructure and stuff, and also to ownership of everything, right? And the quantification of ownership. So for now, I'm going to ignore, and I prefer different terminology. I prefer to call this stuff technomass, a mass of technology. And this stuff, financial capital, is really ownership. It's the quantification of ownership. And ultimately, power, I think. So let's backtrack and think about how you understand money. On a daily basis, you buy things, and what you're doing is essentially trading money for a commodity. Maybe I go to a store and I buy an apple and I give $1 and I get my apple back. And we think of this as reciprocal. If we didn't think it was reciprocal, we wouldn't do it all the time. And in fact, neoclassical economics is the powerful ideology for rationalizing this. It's actually impossible in neoclassical economics to have an unequal exchange if everybody's a utility maximizer and they have perfect information. It's completely impossible to have unequal exchange. So we're conditioned to believe that when we exchange things for money, it's reciprocal. And the anthropologist Alf Hornborg has written on this a lot, so I'm kind of borrowing his ideas. But what you're really doing when you buy something is you're gaining ownership. I give $1 for my apple, and I'm really getting ownership of the apple. And we can abstract away of the particular commodity that you buy. It could be an apple, it could be a car, it could be a patent, which is much more abstract. A patent is ownership of an idea. It could even be more abstract, and you could be buying ownership of an institution. I could be a billionaire and I could buy General Motors if I had $1 trillion. And what does that mean when I buy an institution? Well, first of all, we call it investment. So the terminology is kind of important to how we think about it. But really what you're doing if I buy General Motors, I become the legitimate ruler over General Motors. And General Motors, like all corporations, is a hierarchy. And as the ruler, I can tell everybody who works for General Motors what to do within the bounds of the law. Now, the question is, why do the employees of General Motors believe that I am the rightful ruler? Well, there are many reasons, but I think ultimately hinges on this idea that we believe that when you exchange money for something else, that's fair. So when I exchange capital for ownership, I'm now the legitimate owner of General Motors, and I have the right to rule. So just like kings appeal to divinity, they say, I derive my power from God. God cannot be questioned, therefore I'm the rightful ruler. Well, capitalists say, I've derived my power by investing my capital. And capital monetary exchange is reciprocal, and therefore I'm the rightful ruler. Okay? So this is a powerful ideology. Now, capital is not stagnant. In fact, when I invest it, I gain the right to make a return on my investment, which means I can actually accumulate capital. So this is a very important process, and I'm going to lay out how I think about this with an example. So suppose I'm Bill Gates and I purchased Microsoft. Well, actually, I borrow money from my dad and I create Microsoft. What I do is I hire some employees and we make a profit, so my capital gets larger and I reinvest it and I hire more employees, and this cycle goes in a circle. And when I say hire more employees, I'm using the word hierarchy formation, because really all these institutions are hierarchical. So my capital accumulates and pretty soon I have $1 billion company and I employ 100,000 people. So that's how this capital accumulation works, but there's this other aspect of it which actually capitalists don't think about at all, and really nobody in political economy thinks about at all, which is this evidence that links employment concentration to energy consumption. Now, the leap that I'm making is because corporations are these large hierarchical institutions. The evidence that I showed you in the first half is really evidence for this link between hierarchy formation and energy consumption. So it's this feedback loop. Now this is very different from the neoclassical model. This is the model that I showed you at the very beginning. And this is a model where capital accumulation is literally physical. It's the accumulation of cars and tractors and all the other stuff that we use. And they try to aggregate this stuff and use a production function to predict what output will be. But this is hopeless, right? It's completely hopeless. We can't measure output. I spent half an hour showing you why that's not the case. And Jonathan and Shimsham spend half a book showing you why you can't measure capital. It's the same problem. So the theory goes nowhere. It's a dead end. But we shouldn't neglect physical capital or technomass. It is important, but important for reasons that are completely different than neoclassical economists would have you believe. I've framed growth as this physical process which fundamentally involves energy transformation. Physical capital is important because humans can't eat fossil fuels, right? We need some machine to use it for us. So literally what this infrastructure and technology does is allow us to transform energy into some usable form. So the tractor takes gasoline and converts it into some sort of motion, and then it's able to plow the field, which is what we want. So this is important, and I can show you quantitatively how it's important. So the output of the tractor, the energy use of the tractor, I can measure in terms of its horsepower. Horsepower is a measure of useful work done by the tractor. And that's the red here. And I just took John Deere tractors and I found their largest tractor produced in a given year. And that maps one-to-one basically on the growth of agricultural productivity. Now it's important that I'm measuring productivity here physically in terms of bushels of wheat output per labor hour. So how do we produce more wheat? Well, it's because tractors get more powerful. So you can show this, and you can probably show this in other areas. But what you can't do is what the neoclassical economists try to do, which is add up how many tractors we have and say, we have $100 million worth of capital, and that is why it maps onto growth. You can't do that in any sense at all. Okay? Now, I'm getting to the very end of my talk here, and what I'm going to try to do is pull everything together and try to show you how we can use capitalist power as Jonathan and Shimsham have developed it to explain history. I want to try to explain history in the US. To do this, we need to use this concept of breadth and depth. Now, if you've read Capitalist Power, they do this breadth and depth with profit. I'm going to do it with capital because it's easier for where I'm going. I think it's the same thing because profitability and capitalization are very tightly linked. So I'm going to use a little bit of algebra here, but it's very simple. I define the market value of a company as the letter K, and its employment, the number of employees of that company as the letter L for labor. Now, the goal of every corporation is to increase its capitalization. If we divide and multiply by L, that changes nothing. That's like multiplying by 1. But you can then move these things apart and look at two different ways that capitalization can grow. So if L increases, if employment increases, because the two sides are equal, that's one way to accumulate capital. But the other way, and we call that breadth, or Jonathan and Shimsham call that breadth. The other way is depth, which is literally holding employment fixed and increasing market value, increasing capitalization per employee. And we call that depth. So these are the two spectrums, two regimes of how a capitalist can accumulate. And it's very enlightening. So I think, in my mind, a breadth regime is what I described before, this feedback loop between capital accumulation, hierarchy formation, and energy consumption. That's a breadth regime. Now, capitalists don't care about hierarchy, they don't care about employment, and they certainly don't care about energy consumption of the entire economy, right? Their single goal is to accumulate capital. And if they can do that, if they can sidestep this other stuff, they don't care, they will. If they can accumulate capital, without these other two processes happening, you'll have capital accumulation, but no growth and no hierarchy formation. And I call that's I think what happens under a depth regime. Now this is just conjecture, but it's testable, I think. So my goal, to wrap things up, is to make a model, a very simple model using capitalist power principles that will predict hierarchy formation, meaning corporate employment concentration in the US. So this is the data that I'm trying to recreate. Now I showed you the blue, which is employment concentration, and the red, which is energy consumption. Because they're so tightly correlated, it follows that if I recreate one, I recreate the other. So this is my goal, and this is how I'm going to go about it. I want you to imagine an imaginary economy that has perfect breadth. And what that means is that the only way that any company can increase its capitalization is by increasing employment. Well, what would that look like if I took a whole bunch of corporations now and plotted them? So every dot is a different company, and I plot their market value, or their capitalization, versus their employment. I would get a perfect line, perfect correlation, because the only way that this company here can increase its capitalization is by increasing employment, and it has to move up this ladder. So that's a breadth regime, perfect breadth regime. Now, incidentally, I think it's fairly obvious that in such a structural regime, there would be enormous incentive to increase employment. Why? Well, we assume that every capitalist wants to increase its capitalization. That's like the modus operandi of the capitalist. And they want to increase it differentially, which means relative to everybody else. Well, if let's say this guy wants to become that guy, or beat him, in this regime, as I've constructed it, the only way to do it is increase employment. So there's this tremendous pressure on all capitalists to increase employment. Well, the opposite regime would be a depth regime, but it's easier for me to imagine it as having zero breadth, which means increasing employment is of absolutely no benefit to your capitalization. Therefore, if I plot a whole bunch of different firms, plot their capitalization and their employment, it'll be completely random, right? The only reliable way to increase your capitalization is up, like this. So there's no incentive for increasing employment, no structural incentive. And the correlation is zero. Now, so these are two ends of the spectrum of perfect breadth and zero breadth. And the important thing that I want you to look at is the correlation coefficient, or R squared. It measures how strong the correlation is. So it's 0 here and 1 here. So that's the ends of our spectrum from 0 to 1. So let's now look at some real data. Oh, I always forget this. So my hypothesis is that the correlation between capitalization and employment indicates the pressure to form larger hierarchies. Well, why is that? Well, this is 1, and I've told you that the only way that a corporation can increase its capitalization is by increasing employment. So it follows that there's enormous pressure to increase employment when the correlation is 1. When the correlation is 0, there's no structural incentive to increase employment. So this is my hypothesis. Here's some real data. This is the US in 1950, CompuStat data. So the 200 largest firms in the CompuStat data set when it's ranked by employment. And I've plotted their market value vertically and their employment horizontally. And so the scatter plot is nice, but the important thing to look at is that value there in the corner, the 0.53. It tells you that as I've constructed it, we're halfway between perfect breadth and zero breadth. Now, on its own, that doesn't really mean anything. What I want to know is how it's changed over time. And here's 2013, and things have changed a lot, right? First of all, most of the firms are different, but that's not really important. What's important is that this correlation has dropped significantly, right? So again, we're plotting market value versus employment, and now there's almost zero correlation. Very close. I mean, 0.16 is very low. So structurally, I would say in 2013, there's very little incentive on these corporations to increase their employment. Whereas in 1950, I would say there's quite a bit of incentive to increase employment. Now, what we want, I don't want just these two end points. This is the beginning of when data is available and the end of when data is available. I want everything in between, and that involves making 63 scatter plots, which I didn't want to show you, but I can get a computer to do that very quickly. And all I'm going to abstract out of it is the R squared value. So the next plot shows you only the correlation for those 63 years. And it's the blue curve here. I start at 0.53 and I end at 0.16, but the path that I take is very important. Really downward until 1980 and then kind of flatline after that. So, why is this important? Well, I said that this correlation I've hypothesized is the incentive, the pressure on these companies to grow. Well, that should be related. If it's the pressure to grow, then it should be related to their actual growth rate. And the actual growth rate is the red line here with the scale is over there. I've smoothed it out so you can see the long-term trend. And the long-term trend is very similar to the correlation. So this means it's support for my hypothesis that the correlation between market value and employment is a good indicator of the actual growth of these companies. Okay? So, I apologize that I have to get a little bit technical just so that I can explain where I'm going, but I think it's doable. Ultimately, what I'm trying to explain is this fraction of employment. The top 200 corporations' fraction of total employment. That was what this plot here showed you. That's where I'm going. To get there, I have shown you something, kind of a proxy is the word you would use for the employment of these large corporations, the numerator, the employment of the top 200. So I've got a proxy for that I can use to model it. What I want next, though, is the denominator, which is how can I model the growth of total US employment? So the whole economy. How has that employment changed over time? Well, I can use the same trick now. So this is total employment now of the US economy, and I can multiply and divide by population. That doesn't change anything, but it gives me two ways that employment can grow. It can either grow through this ratio increasing or through population increasing. Now, I think this is fairly intuitive. If the population of an economy increases, then more people are going to be working. That's just obvious, but it's not very interesting, right? I'm not interested in why the population of the US grew. What's more interesting is why the relative size of the workforce, which is what this ratio is, why would the relative size of the workforce change over time? That's what I'm interested in modeling. So I'm just going to use population data as a given, but how can I understand this ratio? And especially in terms of the behavior of capitalists, because that's ultimately where I'm going with this. Well, this is something that I stumbled upon, that there's actually this remarkable correlation between, here in the vertical is the relative size of the labor force, so number of employed people as a fraction of the population. And here is on the horizontal axis, capitalist share of income, capitalist share of national income, which means I add up profits and interest and divide by the national income of the US. So in 1933, we're in the middle of the Great Depression, very few people, like the workforce was very small. A lot of people were unemployed, and capitalists were also making very little. The profit was down, and it was a crisis. Now, gradually throughout the 20th century, capitalist income has increased. It's fluctuated over time, but it's up. We're now at 2006, and capitalist income is at 2006 was at an all-time high. And that corresponds with more and more people entering the workforce. Now, I have some kind of ideas of why this correlation exists, but I don't want to get into them. Just for now, I'm just going to take it as an empirical fact. Because what it allows me to do is replace this fraction here, employment as a fraction of the population. I can replace that with capitalist income share, or model it with capitalist income share. So, last slide before I get to the point. What I'm doing in this model is I'm modeling the top 200 employment, their total employment, in terms of the correlation between market value and employment. And there's some math terms I won't get into what they mean. I have to add a constant and integrate, but I won't get into that. And then I'm modeling total employment in terms of the growth of population times the capitalist share of income and a constant. So when I do that, I get, I think, a very beautiful result. So I took you through a lot of math. What is the point of this? Well, in my mind, the point of this is that I can link, using capitalist power, I can show how capitalists will behave based on the incentive structure of the economy, which is their central goal is increasing capitalization. And when these large corporations are able to increase, or when they pursue increasing capitalization through employment, we get massive growth of hierarchy and of employment concentration. Then the regime slowly shifts until we're here now in 2013, and really very few corporations are pursuing employment as a means for capital accumulation. They're doing other things, mostly raising prices, which is very different. So this allows us to show how capitalists will behave and in terms of capitalist power and the incentive structure of the economy. So, I'm going to wrap things up here. What have we learned? Well, first, neoclassical theory is flat out wrong. it assumes that the economic growth is a free market phenomena, but it's not, right? The evidence is the reverse, that economic growth is related strongly to large firms becoming larger. And I've said ultimately that means hierarchy. And I've argued that we form hierarchies, or capitalists form hierarchies by appealing to capital. And capital is an ideological structure that facilitates hierarchy formation. It's a power structure. And lastly, with this model, I really tried to show how capital as power, the capital as power framework, can connect the behavior of capitalists and the growth of these large corporations with ultimately the growth of the entire economy. Because if I show employment concentration, that's basically the same as showing energy consumption. Okay? I'll leave you with this parting thought from Noam Chomsky, which I love. If you're interested in empirical research, it's really something to think about. Let's focus on simple things that puzzle you, and you'll get far. Okay? Thank you.
Thank you. So thank you very much, Blair, for a very impressive presentation. We have time for questions and answers. The plan was to run this until 5 o'clock, and now we are 10 to 5. However, we'll stay for as long as you have questions. So I open the floor here, asking for the first hand. Any questions? Who has the first?
It's working, but I'm not talking. Can you hear me? Yeah. Thanks very much, Blair. It was very interesting, as ever. I wonder if you've seen Dunbar's paper about the 3 times rule, the size of organizations in a military hierarchy. Do you know the one I'm talking about?
I don't know that I've read his paper, but he has looked at the size, for instance, of platoons in the military, and there are about 150 people.
But if there's a whole hierarchy of those military organizations. It's about 9 or 10. And the interesting thing about it is that they're all more or less 3 times the size of the one below. And I don't understand. I have no idea what that means. I've been fooling around with these numbers, and I don't know how it fits with your idea that some things increase linearly and others increase exponentially. But
well, that number you mentioned, 3, is actually the span of control, the accepted span of control in the military for most operations. And they have a commander, and then below them 5 individuals, but 2 of them are administrative, so kind of at this, it's ambiguous. So that ratio of 3 to 1 between each successive level arises from this span of control of 3. So the military is probably the most vertical institution you could think of. It has a very small span of control. Other corporations would be larger. I don't know if that answers your question.
Yeah, very helpful indeed. I did a very simple-minded thing, like totally simple-minded. The platoon is around 15, I guess, and 5 is that magical intimate group that he talks about. 5 is a magic number, and then 15 is a magic number, and these 3s. And if you take his military hierarchy, you get up to about 9 or 10 levels of hierarchy. Mm-hmm. And if you keep multiplying by 3, by the time you get to 19 or 20, you've got 8 billion.
Yeah.
And I thought, wow, that's pretty interesting. So it's pretty clear how simple it is to run a world. I mean, to me, it always seemed crazy that
Yeah.
we could run a world like this, and yet we can do it because it's only 19 or 20 levels in total.
Yeah. Incidentally, well, because you brought it up, this idea of a perfectly fixed span of control is a simplification. I've looked at the military and other organizations, and the span of control does tend to grow slightly as you go towards the top. So below, for instance, a CEO, there'd be more like 10 people. And then it shrinks as you get to the bottom. So it's not perfectly fixed, but it doesn't matter for my general argument here.
No, you okay?
It's amazing.
Okay.
Now I can explain.
Okay. Next question. Yes. Can you pass on the mic?
Hi. I was just wondering, when you were mentioning the perfect breath, you said about the level of employment, the correlation between capitalization and employment. What happens to capitalization if employment is at 100%?
Do you mean this graph here?
No, the
No?
one before that you had. That one, yeah.
This is not a percentage scale down here. This can grow infinitely. This is literally the size of the firm. So you could have a firm here down that's 10,000 people, and then this might be Walmart, which has 2 million people. There is no 100% because this is, I don't know if I'm answering your question. This can grow forever. I mean, are you saying what happens if the largest corporations occupy 100% of total employment?
Yes.
I don't know. It's never happened.
Or if for example,
There are obviously limits to this process, right?
but in a situation, for example, where in a governmental, for example, the country has 100% of employment, how would you look at the capitalization of that country in terms of would it reach a stagnation point at that point, or could it continuously grow?
I don't know if I understand. It's a nice theoretical question. I can't really answer because I always want to base my arguments on evidence, and no country. Let's look at the evidence for where we've gotten to with the largest corporations. Here, so the largest, so Croatia, for instance, very, very concentrated, but it's harder to read this because I did it in powers of 10. But so Croatia, the 10 largest companies, it looks like about 13 or 14%. Actually, no, because this is an exponential graph. More like 20% of the total population. But we don't have any evidence for beyond that, so I can't really say. But obviously, yeah, I mean, this spectrum ends at 100%, and if I'm saying that it would have to eventually break down, I don't know. But we don't have any evidence for it. So it's an interesting...
Maybe at that point the neoclassicists will stop speaking about perfect competition.
Yeah, I mean, it would be like literally one corporation running everything in a single hierarchy. That would be the limit. We've never come even close to that. Maybe, but I mean, I'm kind of, what I would like to get my hands on is data for Soviet Russia. Like how much of employment was controlled by the central government. I don't even know how to go about doing that, but that would be very interesting. But obviously that system broke down.
Yeah, but you can still investigate.
Yeah, yeah.
Lee?
I had some anecdotal evidence on that. I was in Romania at one point. We were looking at a mine, and we went there at shift change to see what was going on, and there were hundreds of people on the payroll, and there were less than a score of people in the factory. at each shift. So, I mean, it didn't have any relationship to any kind of reality. Blair, I'm basically puzzled, I guess, about the relationship between hierarchy and capital in the end. I mean, at one level, you seem to be implying that that energy and capital drive hierarchy, increase levels of hierarchy. And it seems to me that hierarchy is more or less an independent variable. It's got nothing to do with humanity. I mean, humans are just, I mean, hierarchy is all through nature. It's ubiquitous. It's mostly not studied because it's mostly not even recognized. It's so transparent. So I'm not quite connecting about what hierarchy is doing here, I guess.
Well, that's an open question. I mean, I don't know, really. I mean, I've given you my thoughts about why if a group is to increase in size and still function cohesively, why that has to happen through hierarchy. And so when I say hierarchy formation, really that means more people moving to large companies. And these large companies are hierarchical. So they're no longer, if I'm self-employed, I'm in theory fairly independent to do what I want. But when I give up that independence and I go work for Walmart, I'm told what to do. And that's really what the difference is, I think. The Walmart supply chain, imagine the Walmart supply chain spontaneously emerging from 2 million mom and pop retailers. That would be like the free market delivering what Walmart does. How could that possibly happen? It's an absurdity. Walmart is a centrally planned system where people at the top make decisions and they apply it throughout the whole store. So you go to any Walmart across North America and they all look the same. They all have the same stuff in them. Everybody wears the same clothes. They all have, and that happens only, I think, through hierarchy. It's just impossible that could happen through independent individuals somehow coalescing into this.
I guess that's my problem. It's the only thing because it's all there is. I mean, I can't imagine any. Well, I mean, we can imagine some kind of anarchic system, a human system that might, impose.
The interesting thing is not that we have hierarchies, because I think everybody knows that. It's that it's somehow related to energy consumption, which is not intuitive at all. It's not intuitive to me before I found this. It's still not particularly intuitive why we can't increase, because increasing energy consumption is largely a function of your technology, right? Using cars, and I told you about tractors, and so the question is, why can't we do that in a disaggregated way without hierarchy? But I don't think we can. I don't know. Why not? I don't know.
Sorry. Mm-hmm. Well, yeah, I don't know if you're familiar with the work of Carlota Perez. She's a economic historian, and she looks at economic growth in terms of technological change, innovation, and she sort of sees these cycles where there's sort of a technological revolution, and then it's implemented, and then it's deployed, and then at the point of deployment, there's always change in terms of social organization. So she says, basically in the 30s, there was like the fascist government in Germany, the Soviet government in Russia, the social democratic government in the US. These were all different choices that were made to deal with these new technologies and to deploy these new technologies. So I do think there is, it almost seems to me that you're being far too general in terms of these relationships. And some of the correlations I find, for example, energy consumption and self-employment. Every developed country has a very low level of self-employment. You look at Bolivia, they have a huge proportion of people who are self-employed because the state gives them very, to destitute people gives them very few, support or payments, social service payments. So like the energy consumption, self-employment, it just seems like it's an attribute of developed countries. Like wherever you have a developed country, you have a large government, you have a great deal of employment in the governmental sector, you have low levels of self-employment, you have, for example, lots of lawyers can be associated with, high energy consumption. The reason I'm sort of getting into this is like if I were to ask you, okay, since the financial crisis, economic growth has been low in Canada and globally, and employment is relatively high. What do we do? And I was trying to see, like you obviously see problems with the neoclassical approach, and I agree with you, but it seems like there are a lot of generalities there that can't really bite into that question. What do we do now?
I have no policy suggestions. I'm trying to take a scientific perspective, and just to comment on when you say growth has been low, well, that's GDP, and I've just rejected that whole avenue. In the US, the way I've defined it in energy consumption terms, there's been no growth since 1970 in energy consumption. So, and then actually decline in 2008. Just to comment on your comment on self-employment, yeah, I mean, take somewhere like Cambodia, and this is data from the World Bank, so there could be issues with it. I don't know. I just take the data as is. But for instance, what is the sector where almost everybody's self-employed? Well, agriculture. So this move away from self-employment is really easy to understand because as countries develop, the agriculture sector declines. And that's a trend that's been known for decades and decades. So as they move away from agriculture, they also move away from self-employment. That's not surprising.
Well, just another follow-up in terms of like the power relationship top-down in corporations. I just forgot his name. Who's the fog of war? Yes, Robert McNamara, when he was the CEO of Ford, I believe. He was asked, I think the difference between the lowest paid worker at Ford and his salary was something like 17 times. And he was asked, I think, a fairly simple question, you have the power to pay yourself more, why don't you? And his response was that would be shameful. And like, can you imagine like a CEO today saying something like that? But then you look at, I mean, so there are sort of changes there in terms of that are in addition to sort of the size of corporations, and it just seems like there's more there, and also corporations. There's the difference between ownership and management. But anyways, just some comments.
Yeah. Oh, that's interesting. I mean, the importance of hierarchy for distribution is very important. I mean, the relative pay between each successive level is important, but that's a distribution issue. It's very important. It's something I'm researching. I didn't talk about it today because it's really not relevant. But it has changed, yeah. Like some CEOs make 1,000 times the average worker. Okay, other question?
Yeah, kind of a comment, question. Great talk. It was really enjoyable. Being a political science student, I'm very interested in the what you've shown here on hierarchies and their correlation with energy consumption, which I guess you could take to mean development, whatnot. Specifically, I think you have very interesting things to say about if something, for instance, like direct democracy is really possible. And the gentleman here mentioned something about anarchism and anarchist thought, which seeks to establish a kind of a stateless society where hierarchy is minimized, or at least, if not gotten altogether rid of, minimized, and how people like Chomsky have said that this is possible to have a situation like that while also being highly organized at the same time and highly technologically developed. And I think that's a belief that I subscribe in. However, I'm forced now to contend with some very, very interesting things that you brought up here with the correlation between energy consumption and hierarchy and whatnot. I just wanted to thank you for enlightening me on that. And it's something, because anytime somebody always kind of attacks direct democracy isn't possible for various reasons. You can't communicate over large distances and whatnot. And these reasons are, I think, able to be shown to be rubbish. Yours is a little more difficult to contend with, how you can have that kind of high technology, high organization without hierarchy. So thank you very much.
Well, that's a great comment. I consider myself an anarchist, and I like everything that Chomsky has to say. I'm disturbed by my own research, but I think the most workable vision of an equal society is put forward by Michael Albert. It's called Participatory Economics. And he has this vision of nested committees. So you can, it's a hierarchy in the sense that you have to have nested structures, because it's impossible for everybody to pay attention to everything else, right? That's just an absurdity. So nested structures that each are specialized. But the difference, and the key difference, is that the people would have to have the power to immediately replace the people in any given committee if they behaved improperly. And also, I should mention that there's tremendous difference between a government hierarchy and a corporate hierarchy in accountability. I mean, Chomsky calls corporations private tyrannies, and they are. You have essentially no, unless you're a shareholder, you have no way to influence the CEO. But in a government, at least you can change those in power. And the pay structure reflects that. I mean, government pay is incredibly equal, public sector pay. And corporate pay, private pay is just absurdly unequal. So there are huge differences that I glossed over.
I want to ask a question about sort of the direction of causality here, because in the beginning you spoke about the physical scale of the economy, and I'm just wondering if that's not possibly a bad term to use, because not only because the economy is a problematic concept to me, but because it focuses our attention on the presumption that somehow what society does is trying to produce. And therefore, hierarchies are somehow connected. And throughout your presentation, you speak about employees, and that connotes production. And you show charts that demonstrate what needs to be constructed. So you start from a hut, and you move to a pyramid, and then you move to a huge hydroelectric dam. And all of those things are physical constructs, and again, they are connected to production. And somehow there's this logic that we have more energy consumption, and therefore we need deeper social scaling, we need a more involved hierarchy, etc. And maybe we can reverse this logic altogether. Maybe we should start, first of all, not thinking about the economy, but thinking about society. And maybe we should think of the drive to create social structure. So Lee raised this issue that somehow hierarchies are kind of prevalent through nature, so why should we bother about them? Well, one big difference between human societies and societies of animals is that we change our hierarchies quite deliberately and to a great extent, where animals don't. They have more or less the same structure, and they maintain those structures for the sort of the life of the species. So the emphasis here on hierarchy formation, I think, is very correct. It's the formation and the sort of deformation of hierarchies that we are interested in, the dynamic nature of hierarchies, rather than the very existence of hierarchies. But if we think of hierarchies as being the lead thing rather than the result, then maybe the questions that you will ask will be different. It's possible, for instance, that when you're moving towards high energy consumption per capita, you're creating hierarchies not necessarily for the purpose of production. In fact, much of the production that is taking place is completely unnecessary. And it has to do with power for the sake of power, which will come back to the question that you raised about the possibility of having or moving towards a flatter, more anarchic societies, more directly democratic. Maybe we can get rid of many of those hierarchies because they are really not necessary. They are there for their own purpose. They're created. Now, it's possible that in order to create those hierarchies, you actually need more energy, as opposed to using more energy to build stuff and therefore needing as a side effect to have hierarchies. So I think, to me, it's always to be careful not to be falling back into the trap of economics, as if somehow all those things that are created are necessary for us in terms of the production. Maybe the driving force is the very desire or something built into human psyche or human structures that seeks to create those hierarchies. And that should be the research question.
I agree. I just brought up this slide just because, I mean, most people would agree that pyramids are useless, but yet they were built, and they were built because the pharaoh decreed it. So, but they couldn't have been built if there wasn't an enormous agrarian base. So the way that causality works here, I don't really know. I'm quite confused about it. And you can't get any direction to the causality from the evidence that I've shown you at all.
But we can contemplate it. In other words, we can start differentiating between things that seem to be patently unnecessary for human reproduction and things that are necessary.
And the nice thing about energy is that there's no value judgment attached to it. Like when we say GDP, that's supposedly ultimately linked to utility, and it's supposed to be good, but there's nothing that says increasing energy consumption is good. In fact, it's almost certainly bad given the environmental situation we're in now. So yeah, I mean, consumer culture is, we make a whole bunch of, as you said, useless things, and it sucks up energy. And why do we make them? Well, I don't know.
So just to kind of bottom up here, maybe we make them as a byproduct of the drive to create hierarchies, as opposed to making them for whatever odd reason, and then as a result needing hierarchies. So I'm just asking whether it's worthwhile pursuing two different questions, one from the perspective that you have taken, and another from the opposite perspective, that the driving force could be also coming from the other side. And then the research questions could look differently.
Yeah, absolutely. Oh, I should also mention that I invite anybody who's interested to participate in this avenue of research. You'll notice that I've done snapshots of the global economy and then only time series in the US, because that's the easiest. US data is just really easy to come by. If anybody wants to create time series for other countries, I would invite you to do it, and if you're interested. And maybe we could collaborate on a paper. I don't know. Anyway.
Any immediate volunteer?
Finding data on corporate employment is the hardest to do.
One other comment that I had, which is to complicate things further, but hierarchy or the types of hierarchies that you looked at the very beginning obviously are the easiest ones to find, and they are the direct types of hierarchies. So you look at the corporation, and then you look at the hierarchy within the corporation, or you look at the political economy of a country, and you ask what is the corporate hierarchy. But hierarchies have very involved structures, and it's possible that you have indirect connections as opposed to just direct connections between energy use and hierarchy. So essentially this project, or what you're laying out, is taking the first stab at the relationship, because you're just examining direct relationships between hierarchy and direct energy use. But if you were to think, or others that will join this kind of a project, I think it could be made far more sophisticated, and I say that in a very good way, because I think that this is a completely new trajectory and an incredibly exciting trajectory for analysis of power in society. Because what you are doing here, and I'm saying that for the benefit of people who are not in the room and might be watching and listening to this on a video, is that we looked at the question of sabotage and the kind of the undermining of growth and the creation of all sorts of a form of production that is not useful or not good for human beings. And what you're saying is, but let us look at what is actually growing. In this case is energy conversion, and we cannot deny that the beginning of capital, or from the beginning of capitalism, this has increased tremendously. And ask, well, if we do take the sort of mainstream view that capitalism is about growth, that too, unfortunately for the mainstream, is intimately connected with hierarchy formation and with power. So essentially, we looked at one dimension of it, and you complement it maybe in a bigger way by looking at the other dimension and saying, well, let's take you at your word. Capitalism is about growth, but that's not about competition. That's not about sort of fair exchange. It is about power, and more importantly, about the creation of power or power structures. So I think this is tremendously productive in a research sense, and will open new directions. And I will just want to second your request for collaboration here, because that could be kind of a whole new field, I think, in political economy. Any more comments, please, if you have any, or questions, thoughts, comments? Okay, well, thank you very much. Thank you very much, Blair.